add it horizontally or you can add it vertically. We need to add it vertically because every single file of ours has the same columns, that is order, ID, and so on, all the other things. They have the exact same thing. So that's exactly what we are gonna try to perform. Let's do that. Now, where were we? Yeah, here. Once we go through each data frame, I just need to specify Sales.df dot concat. Concat means to combine or add. We can do it as Sales.df dot. Okay, I think I need to. Oh, because it's empty, I cannot do it. All right. So I'll use Pandas.concat. There we go. In Pandas.concat, you're going to have to specify what are you concatenating with what and what is the axis. Do you want to concatenate them horizontally or vertically? These are the three things you need to specify. Axis, the resulting axis will be labeling 0 to n minus 1. This is useful if you're concatenating objects and in, let's say, indices. So the whole idea is we want to figure out if we are concatenating with respect to rows or columns. So let's do that and let's start with this. Let's see how we can do this. We have a very simple way to perform this. We have a very simple and easy way to perform this, where I just have to specify which are the two data frames I need to combine. The first one is sales data frame, and the second one is data frame. After I combine them, default combination is vertical. Please remember, default is vertical axis combination. If you don't want to perform vertical axis combination, you can do it horizontally as well, completely up to you. You can change it. So as I specified, default axis is 0. That is default, it adds new rows. If you want to add new columns instead, you can make it 1. There's so many other parameters in this. Again, not quite important for us to take a look at it immediately. Let's just go ahead with our current purpose. Once we concatenate them, we need to store the data back in sales data frame, because for the first file, you're going to combine this empty data frame and the first data frame you read and store in sales data frame. For the second file, you're going to combine this already previously existing data frame with the new data frame you read and again store it in sales data frame. You keep repeating this constantly and you'll have your merged data frame. Once you run this, let us print sales_df dot shape. Shape is a function that, sorry, shape is a variable that exists that will tell you how many rows and columns there are. You can see there are 6 columns, 186,000 rows. Let's just print some information. Sales.df dot head. Let's see how our data frame looks like. This is how it looks like to begin with. So this is how you can read your entire data frame. I'm just going to paste this here. So in case you want to work around this in short, you can just take this up and perform this operation. Right. So with this basic understanding and basic idea, let us move ahead from this. Go to the next part. Now, since we have already performed this, since we have already started with the, this operation where we have combined them together, we can start answering the first question: which month of the year has the best sales? We cannot directly do that yet. That's because our sales data is not clean. The first thing you can expect is any data that you will receive or retrieve or get from clients. You cannot expect it to be in the same format you need it. Let's think about it. I will receive some information or sales data from a client. I can't expect it to be in the exact format that I want in order to perform data analysis. That is something I need to do. I need to convert this particular data to the format I want. This process is called data cleaning, or yeah, handling data, missing values, and so on, all these things. So to do that, let's observe what stage our current data frame is in. Let's observe what status it is having. I'm just going to provide or perform data frame sales data frame dot info, you'll get to see what are the values that we have. So we have 6 columns: order ID, product, quantity ordered, price each, order date, and purchase address. Now there's something wrong here. See, order ID is a number. It should not be an object. Product is a number. Product is a name. It's fine for it to be an object. Quantity ordered, price each should not be objects. These are strings again, they can be objects. So there are some things which are objects, but they are not. That's the first thing that we get to figure out. So we see our first problem here, that things are not in their expected data types. Let's see why is that the case. So this is the first thing we always do. Just take a look at that data frame and look at what is its current status, what is its current information. This is the first thing we end up doing. The second thing we do after this is try to see if we have null values or not. Let's take a look at this. df dot is na dot sum. I just want to know how many rows are empty. You can see 40 rows are empty in each. This is most probably the exact same row that we encountered where the entire row was empty. So there might be some mistakes by the client where entire row is made empty and we just have to remove these 40 rows separately. That's what we need to try out. So let's try doing that. Now we have two basic information that we need to know. We know that 40 rows are empty, and we know that all are not in their preferred data types. So let's remove these empty rows first. First step for us to do is removing these empty rows. I'm going to do the following to do that. df dot drop na. We have an inbuilt function called drop na that will delete empty lines. So I'm just going to go back here, back to this cheat sheet, I guess, and walk through drop na. Yeah, there we go. Drop na is an inbuilt function within DataFrame that will delete empty values. Now, here's the condition. How do you want to delete empty values? I'm so sorry for that. In a single row, if all of them are empty, you can delete them. Or other condition is if any of them is empty, if even a single value is empty, you can delete it. Or if some percentage of it, let's say in our case, 60% of this row is empty, or greater than 50% of this row is empty, then you can delete it. There are all these kind of combinations you can perform when it comes down to drop NA, and that is what I want to show you. In drop NA, you can use a keyword called how. Yeah, there we go, how. How is a keyword that will specify under which condition do you want to delete that row. Any or all. All means elements are empty, remove it. Any means if even a single value is empty, you remove it. Apart from these, as I said, there's another option that you can specify. What if there's 40, 50, or 60% of the row which is empty, then delete it? In that case, instead of how, you can use threshold or thresh in short. So this will tell you if 3 values are empty, or 4 values are empty, 5 values are empty, then delete it. Something like this can be done using thresh. How is either for one or all? Thresh is for additional condition. Then whether you want to delete rows or columns, default is to delete rows. Please remember, default is to delete rows, but you can have these conditions to check if you want to delete columns instead of rows or so on. That's another case. Moving ahead from this, the last scenario is whether you want to delete them. Okay, let's add our condition. Drop NA, I'll specify how equals all and axis equals 0. Axis is 0 by default anyway. Remember, it by default removes rows. Axis is 0 by default. It's going to remove rows itself. However, you can change it, so I'm just specifying it for our reference. Then one important thing is in place. You're going to see this a lot in time. You're going to observe this a huge amount of times. In place means, do you want to delete it and create a new data frame as a result? Or do you want to delete these rows and modify the existing data frame itself? Most of the times we want to see how it works, so we delete them and create a new data frame, but we know what we are doing here exactly. So instead of creating a new data frame, we can delete it and modify the existing data frame itself. So that's what we're going to do in our case. So let's just specify here. I want to delete all the rows where every single cell is empty, all the rows particularly, and I want to delete it in such a way that once it is deleted, I should retain or I should have the output in my existing data frame only. So to do this, here's what I'm going to do. I'm going to take Sales.df and do this. But prior to doing that, I'm going to print shape before drop NA is Sales.df dot shape. And I'm going to do the same thing again. Shape after drop NA. Let's see where it went wrong. Oh, I am so sorry. All is a string. Yeah, one minor mistake. So you can see here there were 186,850 rows initially, but then you get to see it's only 305. So there were nearly 500 rows, which is not specifically specified here. So apparently there were about 500 rows which were entirely okay. I'm so sorry. I made a mistake here. This is supposed to be sales underscore here. That's why we got it wrong. Yeah, I'm sorry for that. We got it wrong because I used a different one. So I'm just going to execute from here again. Just these ones. There we go. Yeah, 545. This makes better sense. And now I'm able to make better sense out of what we did. All right. So once we delete this, you get to see we just removed 500 plus rows. Now, because we have removed this, let's see if the data type issue is solved. Because a lot of them were objects. Quantity ordered cannot be an object. Price each cannot be an object. Let's see if that particular issue is resolved. I'm just going to print df.info again. And if you take a look at this, they are still objects, which means there's something wrong here where they are not converted into their proper data types again. So that's one thing that we need to handle now. There's something wrong where it's not converted to a proper data type. So we need to figure out what is the condition or what is the reason why we don't have them in a proper data type. That's the next thing we need to figure out. So yeah, let's go ahead and start figuring out why these are not in their proper data types. Why do we not have them in the data type that we expect to have it in? To do that, we need to find out all the values that do not fit into a particular data type. So there's a couple of ways, I won't say a couple of ways, there are tens and hundreds of ways for you to do that. But I'm gonna try in a certain way to explain. Now, take a look at this. Here, quantity ordered must be a number. We know that in our case. Again, we are just applying all the functions that we know, all the logic that we know on to a particular problem and just one single problem that we're going to try to solve. That is, which month of the year has the best and worst sales? The client wants to know. So whenever they have worst sales, they want to do some more advertising offers and so on. That's what they want to do. And that's what we need to figure out in our case. So yeah, let's go ahead and continue from where we left off here. Now, the problem with this is we have deleted empty rows, but the data type is still not what we expect. To observe and understand this, pick a column that is not a string. Pick a column that is a number or something like that. You have to pick a particular column like this. And here's what I'm going to do. In our, sorry guys, in our current data, I'm just gonna have some water. Apparently, I've been having a throat irritation for the last couple of days, maybe due to the weather. So again, apologies for that. Right. Going back into this, here's what I want to do in short. We have our particular data, and I want to know why certain data is not in its expected data type. There's a function in Pandas called toNumeric, where it tries to convert an entire column to numeric data. So we're going to take our column that is data frame of, again, sorry, it's a function, right? So this should not be what we have here. It's a function. All right. So we're going to take the column that is quantity ordered, and we're going to try to convert this column to a numeric column, because for some reason it's not detected as a numeric column and it's only supposed to have numbers. Let's remember that. So let's try doing that. I'm going to take pandas to numeric, and I'm going to specify within it df of quantity ordered. When you run this, you get to see there's some error. The error it says is unable to parse string quantity ordered. What it's saying is you have taken up this entire CSV file. However, there is some place within it where in quantity ordered, instead of being one, two, and everything, it has quantity ordered as text itself in it. Let's see if we can find it anyway. Oh yeah, there we go. Here it is. So we can find it somewhere in the middle of our entire um, Excel file or data frame here. Remember, first row should not matter because by default, Pandas ignores the first row. If you want to read the first row as well as a part of this and columns will be different, there's another way to do that. But let's not worry about that for now. Our worry is that there are some rows in between, which we saw, which I'm unable to quickly pick up now. Yeah, there we go. Oh, there are multiple of them. You can see here there are quantity ordered as rows. Because of this particular row value within it, it has detected it as not a number. So I need to delete all of these. I need to remove all of these. So here's what I'm going to do. I'm going to run this particular function where I'll add a parameter errors equals. There are two options for errors, either raise or coerce. Please note this. Raise means any element in that column which will have quantity order that cannot be converted to a number, it will raise an error for it. That is the default behavior. Instead of raising, I'm going to say coerce. Now take a look at this. It's going to give me all the values of the ones which can be converted. Now, whichever cannot be converted to integer, it will mark it as NA. Let me just show you what coerce. Yeah, there you go. Here's what you need to know. What coerce does is it tries to go through quantity ordered as a column. When you go through quantity ordered as a column, in the entire column, wherever you find an element or wherever you find a value which cannot be converted to a numeric value or an integer or any sort of numeric value, then you can either raise an error, you can ignore it and keep it as it is, or you can convert it to NaN or empty. That is what we're doing here. We're taking the entire row, entire sales data frames column called quantity order, and wherever it has a value that cannot be converted to a number, we're replacing it with NaN or empty. So this much we got to know. That is, wherever we have 1, 2, 3, and everything, it'll be number as it is. Wherever we have quantity ordered, it becomes NaN. Now, again, to work around this better, I need to retain only these. I need to remove these rows. And I'll explain the logic of how I'm doing this, and we're going to do this in a single line of code. We have 1, 2, 3, and quantity order. This is converted to 1, this is converted to 2, this is converted to 3, this is converted to NaN. Wherever we have NaN specifically, here's what we get to do with it. Here's what happens within it. Within this particular place, I'm going to add an additional function, and you're going to see why I'm doing this. I'm going to add an, okay, hopefully this is just an issue with white. Yeah, I'm going to add an additional function called isNa to check if it is empty or not. If it is empty, it will return true. If it is not empty, it will return false. This is what we're going to do. Wherever it's empty, it's going to return true. Wherever it's not empty, it's going to return false. And that is the information I want. So wherever it is true, that row details I want to see what is the value that cannot be converted to number. I want to know every single value of that. That will help us figure out what can be done to solve it. So a simple logic. I'm just going to check how many of these is NA. So you get to see whichever is not NA, it will give me false. Whichever is NA, it will give me true. And we know what to do with these Boolean values. Wrap it with df.lock. This will help us understand wherever it is true, only those values will be returned. So if you take a look at this, these are the places where it is true. Oh, sorry, not df again. So sorry. Sales data and sales data. Again, I'm so sorry. I keep. Oh, um, it's Sales.df that we are using. Again, terribly sorry for this. Yeah, here because remember we don't have NA anymore. The moment I found NA, I thought about it at that point of time that this is not our content. So yeah, in our logic, let's try this out. We have order ID, product, quantity ordered, price each, order date, and purchase address. These are the columns. There are certain values where the value is exactly quantity ordered and nothing else. It's exactly quantity ordered. And this is what I need to remove. Remaining things is what I need to keep. So to keep remaining things as in which can be converted to number, that is what I want to keep. Which cannot be converted to number, that is what I want to skip. So to keep which can be converted to number, just add a negation. This negation will make all this true to false and all this false to true. And it'll be true when it's a number, it'll be false when it's not a number. And we get our data that we need where quantity ordered is actually a number. If you run this, you get this particular data. And this is the data that we want. Since this is the data that we want, I'm going to save the result here as Sales.df. That's it. So this is going to make sure that Sales.df is updated to consist of rows where quantity ordered can be converted to a number. Wherever it cannot be converted to a number becomes false, which means lock will not filter it and will not have it. So if you print sales.df.shape, you'll get to see it is 5950 last 4 digits. Prior to that, it was 6305. So all these rows are removed. Now let's get to see if we can find its proper data type. When I run df.info, hopefully we get the proper data type. We still don't. So it still has not detected proper data type. Though we removed a lot of things, though all of them are in number format, it hasn't automatically converted to the proper data type, which means we need to convert it to the data type appropriately. That is what we need to do up next. So yeah, prior to that, we have removed all the things that cannot be converted to number, and we have retained the remaining things. The next thing is we just need to convert them to data types, convert them to different formats. That's what we need to do. So yeah, please take a look at this. Please try to work around this. If you're able to work on this, we can go ahead and continue to the next part of it. So I'll just give you a few seconds to just try this out if you'd like to. And with that, we'll move ahead. All right, perfect. Now, yeah, I hope there are no queries. If there are any queries still here, please feel to let me know. Feel free to let me know, and I'll just point out these are the kind of basic steps we always need to follow when it comes down to data, because there are a lot of times, truly, when in real world, when we will get data from end users to perform analysis on, and that because end users won't know what format we need our data in, they just provide the data that they have, and most of the times it's going to be our responsibility to convert it into a proper format which can perform operations that we expect. That's going to be the whole case scenario. Now, with this done, let's go for the next step. We have so far understood how to combine multiple data frames together. We have also understood how to take these data frames that we have combined and clean them. Clean them as in figure out which one of them are empty, which rows are empty, or which rows have NaN, and which rows have non-numeric values, remove them. Once we do that, the next step is to convert it to its proper um, data type. So let's do that. Let's take quantity ordered and convert it to a number. I'll take Sales.df of quantity ordered is equal to pandas dot to numeric. Again, you can convert it to any data type, to numeric, to date time, whatever, whatever different data type you want to convert it to. Apart from string, you can do that. So I'm gonna take df of quantity ordered. I I will convert it to numeric format and I will store it back in the same exact column. Let's do this. Unable to parse. Oh, again, I'm so sorry. This is again supposed to be sales data frame. Yeah, there we go. Now, if we do this, let's print sales.df dot info. You can see quantity order has become an integer. Now we are able to convert it to number. Previously, we were not able to convert it to number because it had some text data. We have removed that text data, retained the remaining data frame. Now that we have retained the data frame with only numbers, we are converting quantity order to numbers. Similarly, I need to convert price each to numbers as well. So let's convert price each to numbers as well. Each belongs with uppercase E. Let's do this. Once we do this, I'll just provide sales data frame dot info. Once you have done this, this is also done. So price is a float value because you have $11.95 and so on. So that is sensible. Quantity ordered isn't. Product, it has to be a string. Order ID, we don't care much. We're not going to use that for now. Purchase address, it has to be a string, but order date has to be a date time object. So the next thing is to convert order date to date time object. This is the next thing we're going to do. But prior to doing that, again, we've crossed our 2 hour mark. So let's take a break now, get back after maybe 15 minutes and continue ahead. By the time I will upload this file immediately. So if you want to take a look at this meanwhile, you can as well, so that you don't have to wait for this file till evening. I'll do that meanwhile. Right. So yeah, let's go ahead, take a little break, and let's connect back by 10:45 a.m. Eastern time. Again, thanks everyone. Also, if you feel I'm going too fast within any of these concepts, or if you feel I'm going a little too fast with each concept and you want me to elaborate it further, please feel free to let me know. Don't hesitate. All right. Thank you, guys.